And hello, my name is Nate Nestler. This is for OpenGL and SDL game development. We're going to continue on what we were at last time, and then also we're going to be doing this is for Hyperactive Studios, but we're going to be doing this laid out here for mouse and keyboard access here, and then I'll show you how to do the basically all quad model here for the cube, if you will. In the code. So let's talk about how to make this cube, okay? And then we'll get into texturing later on with SDL, which is really cool, and OpenGL, and how to use the two together. But alright, and it is a vast library of textures, so it's very cool indeed. Alright, so we're going to create a function called DrawCube. It's going to be void for return and void for passing in, nothing to pass in, open close parentheses, and then open curly brace. GL begin, and this is kind of like, think of it as like a begin and end statement for doing some kind of function or something of that nature. Basically, we're going to begin some operation, and we're going to stay in that type of operation inside OpenGL until we do a GL end. And then that will be defining the operations that we're doing. In this case, we're going to start drawing quads, or shall we say four-sided faces. So basically, let's have a look at this. This is a cube, and I'm going to illustrate this inside of Blender real quick and easy. Alright, so this cube right here shows that it's in all quads and that we can access it. So, you know, if I want to do a particular face, you know, versus another face, it's made up of faces, points, of course, and edges. But just as we talked about before, this is a four-sided face. So you notice there's four vertices per face, and that's referred to in CG as a quad. Okay, so a quad is a four-sided polygon face. So sometimes a polygon object might be, you know, referred to as a collection of polygons to make up an object or a model, and so you might hear it referred to as a polygon or polygons. But a face is also a polygon, of course, because it is a shape. So see some people get confused about that, and a polygon is also a face. So be aware of that, because you know a model could be made up of lots of polygons. In this case, this would be 6 polygons to make up this model here of a cube. And I've seen people think that a polygon is the entire model, where and a face is something separate from that, but it's not. It's, you know, anyways, that's how that is laid out. So I've labeled these: top face, bottom face, you know, right face, left face, etc. And assuming I haven't made any mistakes, which I shouldn't have because it all worked. So okay, so we're going to do our quads here, GL quads, and that means we're going to start drawing four-sided faces, okay? So this is a special command that we're passing into our GL begin to let it know what operation we're going to do. Now it's important to note that if you're doing stuff for cell phones, that you cannot do GL quads. You have to do GL triangles or something of that nature, GL triangle strips, etc. They don't support quads, and the reason why is because you can literally do anything quads you can do with triangles too. So they saw it as superfluous, meaning it's extra stuff you don't need. And because of that, they've made it to where you basically need to draw with just triangles. And the reason why they did that is because there's so much limited space on the cell phone as it is, and they have to conserve battery life as much as possible in all this. So in order to conserve memory size and everything like that, with the limited resources on a cell phone, they removed additional commands, superfluous commands, from the language that aren't really absolutely necessary. So I'm afraid quads went with that, went out the window with that. So be aware of that. I don't know if WebGL in particular supports GL quads. It is mostly an implementation of OpenGL ES, which is, of course, for cell phones. So the cell phones don't allow it. OpenGL ES doesn't, but WebGL may. I'd have to look into it further. There are some variations there. So you know, that might be a case where the command came back into life there. I actually kind of like GL quads, but there's a way of getting non-coplanar, non-manifold geometry if you do have GL quads, because you could literally twist the points in such a way that they would intersect it. And I've already explained all this in the previous video, so you can go back and look at some of the theory videos as to why that could happen and what's going on with that. So, but let's we're going to just use quads for now. And this is for a desktop application, so it works just fine on good old OpenGL fixed function pipeline. Or as to say, OpenGL before shaders. Let's put it that way. I'll explain fixed function pipeline later on versus current nowadays pipeline and how they vary between the two. But we're going to start with fixed just for beginning, and then we'll implement the other one, and that way we ease into it and keep things, break them up in parts, introduce each part, and then that way when we put the parts together, it's not going to be a sudden massive migraine as to understand how all this stuff suddenly works. You know what I mean? That's the way we keep things simple as much as possible and do it in baby steps. It's the best way to handle this because there's so much information otherwise. I've seen people try to show the entire thing and it's just insane. But anyhow, so we have, remember what I said earlier, we have a state machine. So if I define a color here, in this case GL color 3F here, and it's 3F because it's 3 floats here, and it's this particular command. And if we do 1O for red, and then we do half green, and then no blue, and we have to put F's after each one, because if you remember right, F is for floating point, right? So we're telling OpenGL it needs to be floating point, so we put the F's there. Okay, cool. Close the parentheses, semicolon. So now it's going to be this particular color for all the points thereafter until we tell it to do something different. And we tell it to do a different color here, and in which case we have changed states. Some game engines get really fancy, and it's a really good thing actually, not some, a good number of them do state ordering. So basically they try to keep everything in the same state as much as possible before they transition. So you want to do as few state transitions as possible because it actually improves the performance quite a bit. Every time you do a state transition, it really slows down your game. So it's important to reduce your state changes as much as possible. Because it really can massively affect your performance of your game, or your application for that matter. So state ordering here is important. But in this case, this is a very simple application, so every state is just pretty much minimized already because there's hardly anything going on, so it's not really such a big deal. But when you get into a bigger application like a game or something like that, then it becomes really important because you're trying to squeeze every little bit of performance out of every little place you can find it. In order to get more top cutting edge graphics onto the screen and make things look as good as possible so that your game sells and looks absolutely amazing to please your audience. So very important. GL color 3F here is going to be your next color, and then that's just going to be a green. But I digress. Let's stay up here for now. GL normal 3F. Now if you remember right, the normal is going to be the pointing off of the surface, like this red arrow is coming off the surface here. That would be your normal coming straight off, and it's perpendicular to your surface by 90 degrees by 90 degrees and sticks straight off. If you do a cross product of your two angle vectors here, you would end up with your normal facing off of the face of the surface, and that's exactly what we have here with like this red arrow. Would be, think of that as your normal. And so we need to define that normal coming up from the surface, and the way we do that is, since this is the top one and y is up in our application, we've defined y is up. So GL normal 3F, since this is the top face, the normal is going to be facing straight up because this is your y-axis here, right? X-axis, y-axis, z-axis here, okay? Z-axis, x-axis, y-axis. Alright, so because of that, we need our normal facing straight up because the top face, now let's look at it. Because the top face of our cube here, let me switch into face mode, top face of our cube is going straight up. Okay, so that normal needs to be aiming straight up too. Does it make sense? So y going straight up, that'd be that normal is going straight up for that top face, and that's the face we're defining currently right now. Is this top face right here. Okay, so let's have a look at how this is done. So that defines our normal, nothing in X, nothing in Z, all in Y, straight up, 1-0. Cool, so GL text coordinates to F. Now this is if we lay in text coordinates, which we will later on. I went ahead and just defined this thing all out. We could get away without doing text coordinates, texture coordinates. That's what text coordinate is texture coordinates for laying out an image across a 3D surface. And this only has you notice it's a 2F, and we don't have X, Y, and Z. We only have X and Y. Actually, we have U and V, or T and S, if you want to get really accurate with it. So that's all confusing. What is all that stuff I was just talking about? Okay, well, your U and V here is going across your surface here. So think of it as, best way to explain this is graphically. Okay, so your U and V is going across your surface. So like your U would be up here and your V would be across this way. Also, if you want to manipulate your UVs, you can't do that directly. So what you do is you pass it off to two variables called T and S, and this is standard. So like T would be your U and S would be your V going across here. And then you can manipulate those and assign it back to your UVs, and they're thus changing your coordinates for how the image is displayed across the surface of your UVs. UVs are actually the actual coordinates laid out on the model exactly, and so therefore they can't be manipulated. But you can manipulate other variables that you then pass into the UVs, and those variables are called T and S. And the standard, and you always should work with that naming. So that's basically what's going on here. So you have to map a 2D image to a 3D surface. Okay. So that's what's going on with our UVs. Now, if you've been on the CG series, you've already seen how we've been passing in our UVs. Here we're actually defining our UVs and laying them out so that they can be passed into CG or something like that later on. So this isn't going to be a shock for you as to where UVs came from. If you've been in previous series, you've been working with them the whole time and applying textures to the UVs of the surface. Here we're actually defining the UVs for the first time ever. And now you can see how that works. So and then GL vertex here, and this is 1010. So basically we're saying far corner here of the surface. So real quick, let me explain where this UV is coming from. So we're saying, like, for instance, like this point, 10 for V, and well, probably this point in here actually, 10 for V, and then 10 for U. So put it like in this corner here. Okay, so on and so forth, so to speak. Okay, so the vertex. Well, the vertex is 1 unit up on X, 1 unit up on Y, and then -1 in Z. Wow, was I right on that coordinate. Because check it out. If I am doing this, and let me just go into wireframe mode real quick so you can see more easily what I'm talking about. Okay. Alright, and then let's drop out. So check it out. 10, 1 unit up. You see these big squares? It's 1 square up, right? In Y, we did 1 over in X, and check it out, and then we went and did, let's hit from the top view, 1 unit back in Z. Now that's kind of tricky there to see it there. There we go. Well, okay, so I rotate back, check it out, yeah, 1 unit back from the center. So you notice that this is the dead center point here, so going 1 unit back from there. So we've gone up 1, back 1, and over 1, which is this point. So it makes sense that we're going to lay out our UV point at this point on the UV of the surface at the same place we're actually physically positioning this point. And so that's where we place this point. And that creates that vertex here. So that's exactly what we've done here. And I saw our GL vertex 3F for 3 values here, X, Y, and Z, and that positions that point. Now remember, when we passed into CG, we're passing in the X, Y, Z points in there in order to be processed, and so that should be nothing new as far as how that works. So this is where these vertices come from, and this is where the UVs come from too. GL text coord 2F here, so we're laying out the next text coordinate, right? And so we're not going to go anywhere on U, and we're going to go completely only on V here. So where's this going to go? Yes, you guessed it, right here, right? Because nothing on U. So we're going to stay right here at this point, and then we're going to go over 1 on V, which is going to place it right here, okay, for our UVs. And then we're going to go -1 for X, 1.0 for Y, and -1 for Z. All right? So -1 on X would actually put us over here, and then -1 back, let's put us here, and +1 up would give us this point here. So nothing on U, everything on V, unless V was B. Well, maybe V is the up here versus the U. and maybe the U is going across. That's the thing. You can get your U of V's switched around. It's kind of hard to tell which way they go sometimes when you're just looking at it and thinking about it for how they're defined. So in this case, V might be the up and down, and the U can go across. You can switch them interchangeably, actually. And depending on how they're defined or laid out can totally change which way you think things are going. And so that would make sense if that's been swapped around. In which case then, yeah, V up would be this one right here. And that would make sense. So yeah, U is nothing across here, and then it's V up apparently. Okay. For this scenario. Alright, and so that gives us our position point and our UV. Next texture coordinate 0, 0, and then GL vertex, so 0, 0. Please don't make a liar out of me. Should be right there. And then our point in space for that will be -1 in X, +1 in Y, and +1 in Z. And I'm right. So -1 in X, right? So we're going over 1 in X, and we're going to go up in Y and forward in Z. So it gives us that point right here in space for the top face. Alright. And it matches right where our UV space is too. Alright, so then we have our last texture coordinate, and this is going to be 1, 0 in U and nothing in V, and we're going to have 1, 1, 1 for our position. So for our texture coordinate, that is nothing in V and 1, 0 in U, and then 1 over, 1 up, and 1 forward for X, Y, and Z is going to give us this point here. So now we've defined out that top face and the UVs for that face. Now, this is pretty cool because you don't have to do as much in order to make this work now. Because you can literally copy and paste and then start changing stuff around, and then you don't have to type out this whole thing. So literally go away up here to your comment and hit Control-C to copy, and then you're just going to hit Control-V to paste, and you're going to change the values accordingly. So change top to bottom, change your color here to 0.0 and then 1.0 for F for your color, from 0.5. Your GL normal is now going to be -1 because we're doing the bottom face. Now think about that. Why is that? Okay, so if I am going to be in solid mode, alright, so our normal is going to be shooting straight down now out the bottom where it was shooting out the top a second ago. So we need it aiming down like that if it's going to be facing, if the face is going this way, in order for the light to interact with that surface. So that's the direction we need our normal going. So we need to define that. So it makes sense that all we have to do on the opposite faces is literally flip it with a negative or positive sign, opposite of whatever the other one was. Basically think of it as toggling the direction of our vector. So here we put a -1 in for our normal versus what it was for the top face, and it'll flip it going in the opposite direction, straight down. So it'll go -1. And that makes sense because if we go -1 units down, see, 1 unit down from there would make the normal shoot straight down. So that works out. Alright. And again, we've changed states by changing the color here. Alright. So we're going to lay out our text coordinates here. And you'll notice they are identical. And so since I've already talked about how to lay out texture coordinates, I don't need to do it again because it's going to be the same exact layout every single time. So there we go. Very cool. Makes life a lot easier. Alrighty. Now we only need to look at point positions. And you'll notice that nothing's really changed for X. And that makes sense because think about it. Back over here in wireframe again. Notice our point layout in X is identical. I still need to move over the exact same amount for each point. So there's really no difference between our X's, between the top face and the bottom face. They're identical for our directions here, for our movement, to create them. You'll also notice that your Z axis isn't going to change at all either. Check it out. It's identical. Well, why is that? Well, if we come over here and look at our Z axis, I'll go into my point mode here. Check it out. I still have to go backwards exact same distance and forward the exact same distance for each point. So therefore, I don't really need to change my z-axis because it's identical to the top face from the bottom face. So what has actually changed? The only thing that's actually changed is the y-axis, and that is, instead of going up 1, we're always going to be going down 1. So honestly, the only thing we need to change for the y is take all the y's that were positive and just make them all negative. And now, instead of placing those points at the top, it's going to place all those points at the bottom. Like so. Okay? Now, let's move forward for the front face. Great. So now let's select these here, Control-C to copy, and Control-V the paste, and change the bottom face to front face here. GL color 3F 1.0F, comma, which is going to give us full red, nothing for green, and nothing for blue. And again, we're doing another state change for that. Close parentheses, semicolon. So you need to change your 0 here to a 1 and make the rest zeros. Our normal for this, since it's dealing with the front face, is going to be for the z-axis. And it's going to be coming straight at us. And since that makes sense, though, because this is our front face, right? So since this is our front face, we need that z-axis coming straight at us, straight at the camera. So that's going to be the positive direction, to come straight at the camera. Remember, because we moved our cube back -5 units. So moving it back in this direction is negative, right? So facing towards it is going to be positive. That's why when we moved it 5 units positive, it was no longer on the camera, or no longer visible, right? Because we moved it 5 units behind us. So we need the vector facing towards us, which is going to be the positive x in our application. So that's why we're going to have 1, here for our z-axis on our normal. And that takes care of us there. Okay, so GL text chord is identical to above. We don't need to change that. Nothing new there. And then 1.0F, 1.0F gets us started and going. Okay. So our vertex here is going to be this one right here, and that's 1, 1, 1. So check it out: 1 over, 1 up, and 1 forward. It's going to give us that position right there. Okay. Now we're going to define our next one. And well, okay, I'll tell you what. Let's make this easy. Let me just explain how this one's going to work for the front face versus the other face here. So this one's going to be a bit different, and then how we lay it out. Well, let me lay out the points, and then I'll just say the opposite for back face. That's probably the easiest thing to do, right? So we're going to do a -1 here, +1, +1. So how does that go? -1 on x, +1 up, +1 forward. Gives us that point right there. And there's a real pattern to this, actually, once you notice it. Okay, so -1 to the x, -1 down, and then -1 forward again. Now you'll notice all the z-axis are forward. Why is that? Because it's the front face. And there's that pattern I was talking about. See, they all have to be in the front part of the z-axis in order to be the front face. Otherwise, it'd be back here somewhere or something like that. So all the z-axis are going to be positive. So you can just automatically make all the z-axis positive. In this case, on this next point here, we said -1 for x, -1 for y, and then positive z, which gives us that point. And of course, the last point has a positive z-axis, but we need to go over positive in the x-axis, and of course still stay negative in y. And so, yes, positive x, negative y, and then positive z gives you that point there. Okay, that'll be the front face. Now, we're just going to copy our front face, and we're going to paste it. And we're not going to suddenly jump somewhere in the code. Oops. Oh, never mind. It got minimized. This is a feature of a lot of the more advanced GUI editors for programming, where you can actually collapse code, which makes it easy and nice. That way you hide code you don't need to look at while you're trying to stay focused on what you're doing. So it makes life easier, really. except for when I'm doing the video right then. Alright, hit Control V to paste, and change front face to back face, and we're going to change our color to 1.0F, and then 0.5F here for our Z. And this is going to give us total red, no green, and half blue. It's going to give us some kind of purplish color. Okay, so GL 3F is going to be a -1 instead of a +1, and the reason why, of course, is that it is facing away from us. Because again, remember the Z-axis is going away from us in this direction. And so therefore, it is going to be a negative number with this going away from us for the Z-axis. Okay? You'll notice something. Again, it gets into that pattern thing. Notice how these were all positive? Everything else along here is all identical to the front face except for Z-axis, where we just flip it. Now, so it's not about flipping it earlier. So we're just going to put negative in front of all the ones, and all the other values are identical. And then that's going to move all the points, right, from being the front, because they were all positive for the Z-axis, and then move them all back. And they'll all be in the same exact position. And that's going to place and lay out our back face there. Alrighty. Cool. Let's do the left face now. And we're going to have our GL color here, so nothing for red and green. And blue is going to be 1, so totally blue face here. Change it to left face. I'm sorry, paste in your previous one and change it to left face and change that color value. Our normal is going to be a +1 here for the left face. That's interesting. A +1? That would seem to be the right face. Let me double check this. That doesn't make sense to me. -1 on X, -1 on X, -1. Yeah, totally. That is absolutely the left face. Alright, that is the left face. Why is the normal? Interesting. I figured the normal would be going the other way. Let me see something real quick. See if this messes something up. I think that normal maybe flipped the wrong way. Yes, it was. Okay. My apologies. Say that's not right. Yes, that normal for the left face should be going the other way. I'll show you why that was the case. Okay. My mistake. Notice something here. Normal's got to be facing -X in order for it to be going to the left hand side. If it's going to be going to the right hand side, it's going to be a +X here. That's what I was saying. I was looking at the normal. I was like, that can't be right for the left face. It's not right. So it was going to be a -1 there. Everyone's infallible. And certainly me. I've definitely fallen into that category. So GL normal 3F here. And -1 for X, comma 0 for Y, comma 0 for Z, close parentheses, semicolon. And then that'll set up that normal to go to the left, -X. And then here we go for negative values for X all the way across. And of course that makes sense because again of the pattern, everything's going to be on those points on the left hand side for it to be a left face. So that makes sense. So -1 here, and a +1 for our Y, and a +1 for our Z. So where's that going to place our point? Alright, so let's go back to our point mode here, and let's have a look at that. So -1X, -1 in X, +1 in Y, +1 in Z. Just going to put it right there. So that's going to be that point in the X face, for that first point for our face. Alright, okay, so next we're going to do this next point here. You notice our UV still haven't changed, so we're all good. -1.0 F, 1.0 F, comma, and -1.0 F. So our X is of course still going to be -1, but we're going to go up in Y and back in Z. So that makes sense. Always over -1 for X, of course, because we're doing left face. We're going to go up in Y and then back in Z to get that point there. Okay? Alright, let's do our next one here. -1.0 for X, of course, -1 for Y, and -1 for Z. So -1 in x, -1 in y, and -1 in z, right there. Places our point. Alright, let's do the next one. -1 in x, -1 in y, positive z. And of course that makes sense because that'd be the last point. So 1 over x for -1, -1 for y, and of course +1 for z. And that gives us that full face right there. Now it gets simple, because now we're just going to copy and paste this left face here to create our right face. And then Control V to paste it, Control C to copy, of course. And then change left to right here for the face, and then change the color up. So we're going to do 1.0 F here for our color, for our red. And then we're going to do 1.0 for our blue, which will give us solid purple. And then close parentheses, of course. Our normal is going to be a +1 because the right face needs the normal going off in the positive x direction. So of course it's got to be +1 units in that way. Alright. And our text coordinates still haven't changed. GL vertex 3F. And just because we're doing a box, we're not worried about making a unified UVs layout. I'm not going to get into that right now, but we're just doing whatever for orientation. Honestly, if you want to do the orientation of the texture so where they're all facing the right directions and everything like that, then of course it would matter for your UVs and you'd have to reorganize them for each face. But just for slapping something on, we're not bothering to reorganize the UVs. But anyhow, 1.0 F here. Sorry, not thinking. Just need to change all our negatives here on X to positives, and that works out. And all the faces are exactly the same. So check it out. Positive X for all these points. All these points are the same as the left-hand side face, only they're on the other side. So all you need to do is go in positive X direction, and bam, there you go. You got it. And then we'll end that with the GL end here, open close parentheses. Alright, and then close curly brace. Okay, void space draw scene, open parentheses, void close parentheses, open curly brace, and then down the next line here. GL clear, open parentheses here, GL underscore color underscore buffer underscore bit, and then we're going to do a bitwise OR, which is our vertical bar. And you can reach that vertical bar by going to Shift, and then right above the Enter key is the vertical bar. Hit that button there on the keyboard, and it'll give you a vertical bar straight up and down here. GL underscore depth underscore buffer underscore bit. So as a setup, size of a color buffer bit and our depth color or our depth buffer bit here too. Close parentheses. So when we clear it, we're clearing out our depth and our color, or shall we say our background color. Black here is our color bit here that we're clearing out, and then the depth for whatever was in there for our depth for our distance from the back to the front of the screen, off in ZAxis here, is also getting cleared. Okay, so that's what our depth bit is. GL matrix mode, open parentheses, GL underscore model view, close parentheses, semicolon. So let's just do our model view matrix. And we're also getting perspective distortion, so it's actually just more than the model view matrix, but we're setting it to our matrix mode to model view matrix, but we'll also do perspective distortion. GL load identity, open close parentheses, so this lets us wipe out, remember, our transforms. Remember this? This is our identity. And we load that in, and it's going to wipe out what? Our translation, our scale, and our rotations here. Okay? Cool. Alright, GL translate 0.0f 0,0.0f, zoom, close parentheses, semicolon. Now this is what I was talking about, the zoom earlier. Because the zoom is going to determine the distance from the camera. Now we move back -5 units for our zoom. So it is already pushed back the cube, but we could actually set this to a control and drive it with our mouse or keyboard and actually change the zoom in and out according to how we want to do our movements. And that will be driven with that variable there. GL translate F, now remember, because I said this is a state machine, this is going to move back everything. In this case we just have the cube, so but we do want to set up our transforms for our state machine before we draw the cube, and therefore the cube thereafter, because this is a state machine, everything's going to get drawn back 5 units from our coordinate center position of 0, 0, 0 in world space. So this is going to move everything back 5 units. And so that's why this works for all those points on those cubes. Even though we didn't define them 5 units back, they are going to be drawn 5 units back because of the state machine in OpenGL. So GL rotate F here, rotate X, remember 45 degrees, and we're only going to apply it to the X-axis, and we're going to ignore, we're going to do nothing on the Y or Z-axis. So let's just do an Euler rotation around the X-axis, in which we're already familiar with because we've gone over that in the mathematics. Then GL rotate F here, open parentheses, rotate Y 45 degrees, and then nothing on X, and then 45 degree rotation only on Y, and then nothing on Z. Alright? Close parentheses. Then we're going to do a DrawCube here, open close parentheses, that we just did this function, and it's going to do all this code. So it makes it a nice handy dandy method here for accessing this cube function, and then we can, every time we just call this function, it draws another cube. And we could sit there and create all kinds of cubes on the screen if we wanted with this same single function, and now it's just a handy dandy way of accessing that code. GL flush here, now this is going to actually make it display and draw. Basically it's going to make it finalize the drawing, compute the draw, kick it out so that it can be displayed on the screen. Alright, so we're going to do a GL flush here, and now we're doing SDL underscore GL underscore swap buffers open close parentheses semicolon. Now let's change this up. Okay, so basically by doing swap buffers, what we're doing is we're drawing to the background buffer. Then we switch with the screen image. So that's exactly what we do. So we've been drawing to the background. Why we do this is to avoid flicker. You should never ever draw straight to the screen, because if you do, it's going to cause people are literally going to see it drawing to the screen, and so it causes this epileptic flicker that's going to kill tons of people if you do it. And so you definitely want to do SDL underscore GL underscore swap buffers here in order to make it swap like that, and by doing so we don't get any nasty swapping. We just get smooth frame rate and smooth frames. So everything when it displays is fully drawn, and we don't get partial drawings appearing on the screen. So that's why it's important to have always swap buffers going for double buffering, and this is double buffering is what it's called. And then we're going to close curly brace here. Okay? Alright, void keyboard, open parentheses, void, close parentheses here, open curly brace. Now we're going to start setting up our keyboard here. So we're going to do key state equals SDL underscore get key state, open parentheses, null, close parentheses, semicolon. Okay, so this null being passed calls to SDL to tell it get all the keys that are possible. And so that's important because now we're going to grab all the keys that are available and not just some of them. Okay, we can specify to only grab certain keys if we want, but this rate we're grabbing all the keys from the keyboard. SDL underscore enable underscore key, not underscore, sorry, SDL underscore enable key repeat, camel cased, open parentheses 1 comma 10 close parentheses semicolon. Okay, it's important to note this first number is the delay number, and the second number is the repeat frequency, if you will. So, and this is, like milliseconds. So if you want to add a delay before, like, say you're holding down the key and then it starts repeating, you can do that. In my case, I made it very small. I made it only 1-0. So it's going to go super quick. In the case of 10 here, I'm repeating the execution of this command every 10 milliseconds. So it's going to happen pretty quick. I can change the speed of this even more so if I like, and I could even set up a variable for delay and speed to be driven outside of this, so they could be changed on the fly or in some kind of attributes for like a game configuration editor or something like that for the player that's playing the game. Alright, and then if here oh yeah, I'm sorry. By the way, when it's done, it returns with a pointer list of all the keys and their state, were they pressed or not, basically. And then we can find out if they were pressed or not. Remember, 1 is going to be a true and 0 is a false. So that's how it replies with the keys. If the key was pressed, it's a 1, and if it's not replied, if it's not pressed, it's going to be a 0. So that's why we can use this if structure here. So in our key array list, if you will, pointer here, it's an actual data array. If open parentheses here, key state here, open bracket, SDL underscore left. Now this is a special command inside of predefined variable here. Well, it's not a variable. It's a constant, if you will, and holds a bitwise attribute that recognizes that this is the left arrow key on the keyboard in SDL. Close bracket here, close parentheses, and this makes it execute really fast, and it lets it store really easily and really quick by doing bits. Okay, and we can find out for that value if it's 1 or 0 stored in there for true or false. Rotate y minus equals rotate y speed, and when we put the left arrow, it's going to rotate. It's going to do a negative whatever rotate speed is. Negative equals to our rotate here, and so it's going to subtract a value from our y rotate here while the button's being held down. And since we have auto repeating every 10 milliseconds, it's going to delete that value repeatedly as we hold it down for however long we hold it. And so that gives a smooth movement. I'll show you what it does. It gives me smooth movement when I'm holding down the left arrow key to make it do that right there. It's going to run at that speed. If you remember right, the speed we have set for our rotation is up here for our speed rotate, and it's 0.5 for units, degrees, if you will, for our rotations. Okay, OpenGL does do the rotations in degrees and not in radians, and so that's something key to remember here. So wherever the rotation speed is set depends on how much is deducted from our rotation, and then of course what we have for our repeat speed here is going to determine how fast it repeats and how fast it gets rotated too. So we got really two attributes here that are defining the speed of the rotation. Okay, so if key state here, SDL, now we can just copy and paste this top one right here, right? And then we can just paste it down below, not minimize the code, and then we'll just change our left to right here, and then change our plus, our minus to a plus, and that's all we have to do. And now it's going to rotate to the right. Paste again, and you'll have changed your left here to an up, like so. And then you're going to change your rotate y to an x, and you still have your negative equals. And we're going to say our x from our y to our x right here for our speed, and then that's going to let us rotate upward when we spin our cube. So check it out. When I hold down the up arrow, it spins it like that along the x-axis. And then if I hold down my right arrow, it's going to spin it like so along the y-axis. And this makes sense if you think about it. Remember, because our y-axis is going straight up and down, right? So our rotations here about the y-axis is going to make it rotate left and right. Whereas the x-axis is what? Going out and this way, right? So rotations going about that axis are going to be going like this, which is going to make it rotate up or rotate down depending on how you move across the x-axis. So we're rotating about the x-axis or about the y-axis, and then so that's why it's working the way it is for its rotations here. Okay, cool. Copy and paste this next entry out, and we'll change up to down, and then we'll add a if you didn't copy this particular one, then you did the other one, you'll need to change this to x plus equals here and change that to an x also. Otherwise, all you have to do is change this to a plus from a minus, and then you're good to go for up and down for rotations. And of course here I'm hitting the down arrow, and we're seeing how that affects it. Okay? And this is called direct keyboard access instead of SDL. We actually got 3 different ways of accessing keyboard input within SDL, and that's either through a waiting system, which is how most applications are written, but it's not a good idea for a game. Basically, we stop all background processing. The computer does nothing, and we just wait for someone to do something. Then we go off and do whatever they wanted to do from a click, and then come back and handle keyboard access or mouse access. And this is probably the most inefficient way to do it, actually. But yet that's how most applications are written, because it's simple to do that way. That's why it's written that way, for ease of coding, if you will, not because of the best method. And then there's polling events. Polling events are great because it goes through polling actions and see what something's done, and then you go off and do a background event and come back and poll again. And so this allows you to have stuff running in the background while you're still checking to see if there's any kind of actions happening. And then there's direct access, where you directly access the keyboard or mouse, and here we're doing a direct access of the keyboard. I find you get the most control over direct access, and it's my preferred method. But direct access allows you to have things running in the background also. So while the user's doing or interacting with stuff, you have other things that are computing off in the background at the same time. And so that's a very efficient way of doing it. Either polling or direct access end up being an efficient method. I just like direct access because it allows for more functionality, I think, in my mind for handling this stuff. It allows me to do, I think, easier and better programming for breaking this stuff up. Okay, so with that said, in the next video we'll go over the rest of the SDL, setting up the window and breaking it down, and how to also do mouse events and how to control them and drive them. Okay, with that's been SDL programming with OpenGL, and we looked at how to do some of the OpenGL programming in this and a little bit of the SDL keyboard interactions. My name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.